So let's start today's class. The class is Computer Organization, Module 4, Lecture 3. Now, we learned about that different types of techniques to increase the performance of a computer. We know that the one technique is the increase of the clock rate. That means if we increase the frequency of the instruction, clock rate means 1 by t is equal to frequency of the instructions. That means the number of the instruction executed per second. If we can increase, then the performance of the system will be increased. There is another technique to increase the performance of the machine, and that is called the increase the number of the instruction that can be executed simultaneously. Okay, so one thing that we can increase the clock rate to increase the performance of a machine, and another is that we can increase the number of the instructions that can be executed simultaneously. That we can do. Now in the second technique is actually implemented using pipeline. Okay, now what is pipeline? Why pipeline is used? We'll tell later. Now pipeline is a technique where more than one instruction can be executed simultaneously. Obviously, that if we increase the number of the instruction which can be executed simultaneously, the performance of the system would be increased. How? It will be clear from this slide. Now see here in this slide, we'll learn about the what is the principle of pipelining. Remember that in all the modern system or modern computer, pipelining is one of the important concepts. To increase the performance of the system, all the modern computers use the pipelining concept. Now what is pipelining concept and why this concept is used in the computer system? It will be clear from this example. See here in the left hand side, I have shown one system, the system in a laundry house. In the laundry house, see there are the 3 steps for washing the clothes. Number 1 is this step. This is the number 1 step. That means the cloth is washed. Number 2, the cloth is dried, and number 2, the clothes are folded. Clear? So this is a laundry house system where the clothes are first washed, then dried, then folded. Clear? Now suppose here there are the 4 set of the cloths here. The cloths are A, B, C and D. Clear? Now for washing purpose, this is the first stage is the washing purpose. The time required is the 30 minutes. Clear? Then for the drying, the next 40 minutes you use for the drying of the cloths. Then in the next 20 minutes cloths are folded. So for completion of one set of the cloths, this is the one set of the cloths A, the time required is 30 plus 40 plus 20. Clear? Again I repeat, these are the 3 stages for washing the cloths, and for completion of the washing the cloths, the total time required is 30 for washing the cloth, and next 40 minutes it is dried, and the next 20 minutes it is folded. Clear? So for one set of the cloths, the time required is 30 plus 40 plus 20. Clear? Suppose there are 4 set of the cloths A, B, C and D. Now the thing is, question is, then what is the total time required for completion of the tasks? This is the task A, B, C, D, and this is the order of the tasks. That means first will come A, then B, then C, and then D. Now see what is the total time required. So for washing the clothes A, the total time required is 30 plus 40 plus 20. Then for B, again 30 plus 40 plus 20. Then for C, 30 plus 40 plus 20, and D also 30 plus 40 plus 20. So we know how to find out. We have to add all the times. That means 30 plus 40 plus 20 plus 30 plus 40 plus 20 plus 30 plus 40 plus 20 and plus 30 plus 40 plus 20. So total time required for washing the 4 set of the cloths, which comes in a sequential order, is 30 plus 40 plus 20 into 4, because 1, 2, 3, 4. So 4 into 360 minutes, that means the 6 hours. So total time required for washing the 4 set of the cloths is 6 hours if I do in this type of processing. Okay, this is the left hand side. Now see here, the same thing we are doing in the right hand side, but using the pipelining concept, or sometimes it is called assembly line concept, which is used in the industry. So what is the concept? See here, I have shown you the 3 stages. One is, in the first stage, clothes are washed. Second stage, clothes are dried, and third stage, clothes are folded. So here, these are the independent stages. That means they are not dependent on each other. They can execute it independently. So see, in the right hand side, what is the example? First, at the first 30 minutes, A is washed. Okay. Then 40 minutes, in the next 40 minutes, A is dried and B is washed. Again, I repeat, first 30 minutes, only A is washed. And now the cloth will be taken from here to here. So this is empty. The first stage is empty. So in the next 40 minutes, A will be dried and B will be washed. Why? Because there is no cloth in here in this machine. And the next 40 minutes, A will be folded, B will be dried, and C will start its operation. That means C will be washed. Again, next 40 minutes, it will be complete here. A will be complete here, but B will be complete in the next 40 minutes. B will be folded, C will be dried, and D will start washing. Okay, in this way, it will complete here. All the 4 operations, A, B, 4 set of cloths will ended here. That means A, B, C, D. Okay, now see here, in the 40 minutes slots, A and B both are working. That means this is the simultaneous working. In the next 40 minutes, A, B, C operation is going on all the set of the cloths. That means this is a simultaneous or overlapping of the operations. Okay, so here, see here in the left hand side, there is no such overlapping, but here is a overlapping of the operations, different types of operations, because the stages are independent and 2 different types of stages on 2 different sets of the clock can be executed. Clear? So what is the total time? This is the total time required. Now we calculate the total time. What is the total time? Total time required is 30 plus 40 into 4, because this 40 plus 40 plus 40 plus 40, that means 40 into 4 plus 20. So 360 minutes, that means 3 hours 30 minutes. Now see the difference. In the left hand side, total time taken for washing the cloth is 6 hours. And here the total time taken for washing the same set of the cloth is 3 hours 30 minutes. That means almost half. So this is the efficient. And the right hand side is the principle of the pipelining. Why it is called principle of the pipelining? Because in this case, there is a overlapping of the different types of stages. That means at the same time, 2 different stages can be executed. See, at this 40, this stage, these 2 different can be executed parallelly. In this 40, this and this, they can be executed parallelly. So using this overlapping of the different types of the stages, we can do the pipeline operation, and obviously the performance of the system will be increased. From here it is clear, because this takes the total 6 hours and this takes almost half, that means 3 hours 30 minutes. So this is the actually the principle of pipelining. So from this example, you will be clear what is the principle of pipelining. Now the same technique is used in the computer system for the instruction of the execution of the set of the instructions. Same technique of the pipelining is used. So as I have already told you, for running the system in the pipelining, you have to divide it into the stages. In case of the washing the cloth, there are 3 stages. Similarly, we have to divide the instruction into number of stages. We already know that an instruction can be divided into 5 parts or stages. Clear? So what are the stages? The stages are instruction fetch. You know what is instruction fetch, instruction decode, memory read, execution, memory write. That means there are at most 5 stages in a pipeline. Clear? So we can design in a instruction. So we can design one instruction pipeline. Clear? Now see here. Suppose we are using a non-pipeline structure. That means there is no pipeline system. We are only executing one instruction after another. So this is the one instruction, instruction fetch, instruction decode, memory read, execution, memory write. That means one instruction enters in this hardware, suppose this is the hardware of instruction, it will go all the 5 stages and it will go get the output from here. Obviously time will be required. You know, you have to add the stages time. That means this stages time for the IF plus time for ID plus time for MR plus time for EX plus time for MW. Suppose there are 2 instructions. That means first one instruction will be completed, then another instruction can start. If I use a non-pipeline structure, again I tell, if I use a non-pipeline structure, one instruction will end. After the completion of the one instruction, another instruction can start. But when I use a pipeline architecture, obviously there is a overlapping of the instruction. See there in the table, it will be clear. Suppose these are the T0, T1, T2, T3, T4, T5. These are the time instance of the pipeline. Clear? So at first T0, I1 will I1 will be fetched. Okay, at T2, I1 will be decoded, I2 will be fetched. Similarly at T3, I1 will be memory read and I2 will be decoded. Similarly at T3, I1 will be executed and I2 will be memory read. And at the T4, I1 will be memory write and I2 will be executed. And at last, I2 will be memory write. So these are the stages if I use a non-pipeline processor. So obviously for non-pipeline processor, so these are the time period for a pipeline processor. That means one stage should have completed inside starting from this and it should be completed within this. This is a one time period. Similarly, another stage should start here and it should be completed within this. Another stage should start here and it should be completed within this T2. Another stage, it will start here and should be completed within T3. In this way, it will go. Now, as we know that, as I have already told you that pipeline has to be divided into number of stages. Clear? So these are the different stages. Instruction fetch. This is a pipeline structure. See here, this is a pipeline structure. This is a non-pipeline structure. There is no division of stages in the non-pipeline structure. Okay, but in the pipeline structure, in the hardware, you have to make the division in the stages. Clear? So this is the hardware of a pipeline structure. So this is the first stage, instruction fetch, S1. Then comes the instruction decode. This is the S3, memory read. S4, execution, and S5 is the memory write. S means the stages. So these are the 5 stages. Here you can observe that between the stages, there is a latch or temporary memory. Latch means temporary memory. So between this and this, there is a temporary memory. This and this and this, there is a temporary memory. This and this, there is a temporary memory. And this and this, there is a temporary memory. Now the question is, what is the function of the temporary memory? Now temporary memory is actually used. Suppose at the stage T0, what will happen? I1 will be executed. Instruction fetch. Okay, at the S1, that means the instruction fetch at the I1. In the second T2, I1 will be decoded, so I1 will go here and I2 will be fetched. Now the thing is, which portion of the instruction will be decoded? The decoding portion will get, instruction will get the decoded part from the fetching part. Clear? Because this fetching part will go to in the decoding part. One thing you must remember that in the second cycle, that means suppose T1, when instruction IF, instruction I2 will be fetched and instruction I1 will be decoded, the thing is, instruction I1 will get the data from instruction fetch stages. Now the problem is, if at the same time I2 is written here and I1 is read from the instruction fetch, because second stage of the I1 is the instruction decode, what will be the problem? There is a problem that it will I2, because this is the second stage, I2 can overwrite the instruction fetch done by the I1. Clear? Again, I repeat, there is a problem that in the second cycle, I2 can overwrite the data, that means the instruction fetch data by the I1. Clear? Because it will transfer the data from here to here, and at the same time, I1 will transfer the data from here to here. So there is a clash. For this reason, at the first stages, the data which I1 will get in the instruction fetch stage, it will store into the temporary memory, such that in the next cycle, that means suppose here in the T1 cycle, when it will be decoded, it will take the data from this latch, not from this stage. So there will be no problem, because it will take the data from this latch, and I1 will write that, I2 will read the data here, and I1 will take the instruction data from here. Again, I tell, in the next cycle, I2 will write the data here, and I1 will take, that means instruction decode data from this latch. So there is a no chance of collision of the data. Okay, for this reason, always remember, one latch is present in between different stages in a pipeline structure. Okay, now suppose different stages have the different time period. So what should be the time period for this T0, T1? This time period should be maximum of this TS1, TS2, TS3, TS3, TS4. Because if I take less than that, there is a possibility that one of the stages cannot complete within this time. So this time should be maximum of the time taken by this stage, or this stage, or this stage, or this stage, or this stage. Clear? So we have to take maximum of TS1, TS2, TS1, where TS1 is the time stage for the 1, TS2 is the time stage for the 2. Similar, TSN is the time for the stage n. So we have to take the maximum of this plus IT. IT is the latch time. So this is the time period. So this time period is the maximum of the time taken by the stages, maximum time taken by the stages, okay, plus the latch time, because we have to consider the latch time. Latch is a memory, so there is a memory access time. So this is the time period. So this time period is actually this max TS1, TS2 up to TSN plus IT. So if I got the time period, we'll easily get the frequency of the pipelining, which is the F is equal to 1 by T. Clear? So now here it will be clear. This is called the space-time chart or Gantt chart. Now see here, suppose we are using a set of the instruction. In the set, there are the 3 instruction I1, I2, I3. Clear? That means that N is the number of the instruction. And the system has the S stages. S may be any. Here the S stages is 1, 2, 3, 4, 5. S is the number of the stages. Now if I use a non-pipeline processor, see what is the total number of cycle is required. So as there are 5 stages, so I1, 1, 2, 3, 4, 5. 5 stages are required for I1. Then again 1, 2, 3, 4, 5. 5 stages are required for I2. And again 1, 2, 3, 4, 5. 5 stages are required for the I3. Just like the laundry definition. So what is the total cycle required? Cycle required is, there are 5 stages and there are n number of the instructions. So n into s, that means here it will be 15. See here 15, that means there are 5 stages and 3 instructions, I1, I2, I3. So 5 into 3, 15 cycles are required if I use a non-pipeline processor. Clear? Now see what happens if I use a pipeline processor. In the pipeline processor, see I1, in the next cycle I1 and I2 will go for the I1, and in the third cycle I1 will do the S3, I2 will do the S2, and I3 will do the S1. So if I draw this chart, here I3 will be completed. All the instructions will be completed here. Okay, here in the previous case it has completed here, it will be completed here. So what is the total cycle required here? Here 1, 2, 3, 4, 5, 6, 7 cycles required. Okay, why 7 cycles? See, the first instruction takes S number of cycle. S is the number of the stages to complete it. So for completion of the first instruction, it requires the equal number of the stages cycle. So here there are the 5 stages, 1, 2, 3, 4, 5. So 5 stages, 5 cycles are required for completion of I1. 1, 2, 3, 4, 5. After 5 cycles, I1 will be completed. Now see, after the completion of the first cycle, in each cycle, 1 instruction will be completed. Now see here, after the completion of the 5 cycle, then the next cycle I2 will be completed, and the next cycle I3 will be completed. If there are any instruction I4, in the next cycle it will be completed. So see here, what is the total cycle? Total cycle S is required for the first instruction, and what is the remaining number of the instruction? N minus 1 number of instruction, because n is the total number of instruction. Each cycle 1 instruction will be completed, as there are n minus 1 cycle. So n minus 1 instruction. So n minus 1 instruction will be required again. So S plus n minus 1. Again, I repeat, first instruction will complete in the S cycle. Remaining number of the instruction is n minus 1. Each cycle one instruction completes. See here in the next cycle one instruction, here one instruction. So we require for n minus 1 instruction, we require n minus 1 cycle. So total cycle is S plus n minus 1. So here if I put here 5, S is equal to 5, n is equal to 3. So 5 plus 3 is equal to 8, minus 1, 7. So it will require the 7. See here, total cycle here is 15, here is 7, half. Okay. Now see, that means if a system has n is the number of the instruction, okay, and speed up n is the number of the instruction, stage is S, then question is what is the speed up of the system? So you know number of the cycle in the non-pipeline processor is ns. I have told in the previous slide. Number of the cycle in pipeline processor is S plus n minus 1. The speed up means is number of the cycle in non-pipeline processor by number of the cycle in pipeline processor. Clear? So what is the definition of the speed up? Speed up means the number of the cycle required in non-pipeline processor by the number of the cycle required in the pipeline processor. So ns by S plus n minus 1. So in the previous case it was 15, ns was 15 and n plus s1 was 7. So what is the speed up? 2.14. 15 by 7 means 2.14. That means more than double. See here, if I use the pipeline, we will get a speed up more than double. So this is the thing for using, this is the reason for using the pipeline to increase the performance of the system. You will getting the speed up more than 2 times. Okay, so this is the principle of the pipeline, and this is the performance if I use a pipeline. Clear? Now see here, though we are using the pipeline, the thing is not so smooth. Why? In the previous case, we have seen that there are, if we use the 3 instructions and each instruction of the 5 stages, we require n plus s minus 1. That means 8 number of cycles are required. But if in the instruction, one of the instruction or 2 of the instruction is a branch instruction, what will happen? See here. Branch instruction means if condition satisfied, we will go to one address, otherwise we will go to the another address. That means if the condition is satisfied, we will go to some instruction, otherwise we will go to the some another instruction. So there is a trade-off between the 2 types of instruction. Either you go to one instruction or we go to an instruction. Suppose here the I1, I2, I3. I2 is a branch instruction. And if the condition, branch means there is a condition or some loop. So if the condition is satisfied, we will go to the address XX. XX may be any address. That means the instruction written at the address XX. Otherwise, we go to the address of the instruction I3. So we may go to the I3 or we may go to the XS. Now the problem is, if here this is a pipeline processor, I1 starts, then I2 starts. If I start the I3 here, the problem will be processor will only know what is the next instruction after the completion of the I2, because I2 is a branch instruction. So processor here in this position only know what should be the next address, whether it should be the I3 or it should be any other instruction, I4, I6, I11, I100, anything. So processor cannot take the decision until it reaches the last stages. That means the S5 stages. Now if I3 starts here and here I2 finds out that the next instruction is not I3, it is the I4, then it has to discard all the instruction executed here or here. Clear? Again I repeat, if it finds that in this stage, after completion of the branch instruction, because I2 is a branch instruction, that the next instruction is not I3, it is some another instruction, I4, I5, I6, then it has to discard or flush out all the instruction following the I2. That means it has to discard all the instruction which starts here, 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 and here. Clear? Again I repeat, if I2 is a branch instruction, then processor has to wait until the last stage and it has to discard all the instruction following the I2. That means the instruction which starts in the 3rd cycle, 4th cycle, 5th cycle, and 6th cycle. Clear? only it can start the instruction here after the completion of I2. So here it is written as no. That means no operation. That means pipeline will be stalled or stopped if I2 is a branch instruction. Clear? Pipeline will be stopped and only the instruction in the pipeline can be started after the completion of the I2. See here, suppose I1 start here, it's okay. Then I2 here completes and it finds the next instruction is I3. So I3 will start from here. Then it will go in the pipeline I3. If it is I4, after I2, processor finds the next instruction is next branch instruction is I4. So I4 will start from here, then here, then here. Okay. Now, if I2 is a branch instruction, find out what is the total number of cycles required. See here, it starts from here and here it goes here. That means total number of cycles now is 11, but it should be 8. In the previous slide, we have found out that is 8, but here it is 11. Why this is the penalty? What is the penalty? Penalty is 4, because previously we find out it was 7, n plus s minus 1, that means that was 7. We have to give the penalty of 4 cycles. Okay, that means that is 11. Now, what is the 4 cycle meaning? 4 cycle meaning, see what is the number of stages here? Number of stages is here 5. So we have to take the penalty of 4 cycles. That means 5 minus 1. That means if the number of stages is n, we have to give the penalty of s minus 1. That means s minus 1. Okay, so what is the time required? So what is the time required for if there is a pipeline pipeline processor n plus s minus 1? So s plus n minus 1 plus penalty is s minus 1, number of stages if there is one branch instruction. Remember, here the branch instruction is 1. If there is 2 branch instruction, we will be multiply the penalty, that means 2 into s minus 1. If there are m branch instruction, the total time will be total cycle will be s plus n minus 1 plus m into s minus 1. We have to multiply this penalty with number of branch instruction. If the branch instruction increase, this penalty will be increased. Obviously, the total cycle required for completion of the instruction will be increased. Clear? So this is the total cycle. Now see here, the question is, a system has n number of instruction. Clear? Probability of branch instruction is C. That means out of the 100 instruction, suppose the 10% is the number of the branch instruction. So probability is 10 by 100. Clear? So probability of branch instruction is C. What is the speed up if A stages pipeline is used? Clear? So number of the cycles in non-pipeline processor, this is obviously as before ns, because whether it is a branch, non-branch, it will not affect. So it is always ns. So number of the branch instruction is nc, because c is the probability of instruction of branch instruction, n is the total number of instructions. So what is the total number of branch instruction? N into c. That means c means suppose there are out of the 10 probabilities, suppose out of the 10 there are 2 instruction are branch instruction. That means probability of branch instruction is 2 by 10. Suppose there are 50 instructions. So 50 into 2 by 10, it will be the total number of branch instructions. So total number of branch instruction will be n into probability of branch instruction. So number of the cycle in the pipeline processor, what I have already told. This is s plus n minus 1. So what is the penalty? For each branch instruction, penalty is s minus 1. So there are nc number of branch instruction. Number of the branch instruction is nc. So total cycle will be nc into s minus 1. So this is the total cycle, s plus n minus 1 into nc into s minus 1. Clear? So what is the speed up? Speed up formula is same. Number of the cycle in the non-pipeline by number of the cycle in the pipeline, though here branch instruction is there. So ns by s plus n minus 1 plus nc into s minus 1. Suppose the question is if the number of the branch instruction is 0, so probability will be 0. So c will be 0. The formula will be ns plus s minus 1. The formula we have learned in the previous slides. Okay, that means if the probability of branch instruction is 0, our speed up will be maximum, because ns plus s plus n minus 1. Clear? So this is the speed up if I use a branch instruction pipeline with the branch instruction. Clear? Now in the previous example, what is the probability of branch instruction? I1, I2, I3, three instructions there. One instruction was branch instruction, so probability was 1 by 3. So what is the number of the instruction? Number of the instruction was 3. Total number of the instruction, probability of branch instruction is 1 by 3. So what is the total number of branch instruction? 3 into 1 by 3, n into c. Okay, n 3, c 1 by 3. So 1. So that is the I2. You know that is the I2. So speed up is 1.36. Previously it was more than 2, but due to the branch instruction, one penalty is added. Now our speed up is decreased to 1.36, but still it is more. Okay, more than 1. Okay, so this is the speed up if I use the branch instruction. So total number of the instruction cycle, each instruction contains s. So this we know that if there is a branch instruction, this is the total cycle required. S plus n minus 1 plus nc into s minus 1. So one instruction require s stages. So total number of instruction cycle will be one instruction cycle composed of the s cycle because s is the number of the stages. So total number of instruction cycle required is s plus n minus 1 plus nc into s minus 1 by s. This is the total number of instruction cycle required for a pipeline processor. And average number of the instruction executed by instruction cycle will be I. This will be total number of instruction is n by inc. Inc is this total number of instruction cycle. So average instruction executed per instruction cycle. This is the total number of instruction cycle. So average total number of instruction executed is n. So average instruction will be n by inc. So ns by this one. So this is actually the speed up. See here. Average instruction executed per instruction cycle is equivalent to the speed up of the system. Clear? Now if the question is, if the number of the instruction is very high, that means it is infinity. If we use a very high number of instruction, what is the limit for the performance? So limit n tends to infinity, that means number of the instruction is very high. So here I divide. So limit ns plus s plus n minus 1 plus nc into is, this is the speed up or average instruction per instruction cycle. So numerator and denominator is divided by n. So this is s by n plus 1 by 1 minus s plus this. So as n tends to infinity, if I put here, it will get we will get the 0 for this term and this term. And so if the this is the ultimate result s plus c into s minus 1. That means if the number of the instruction is very high, this is the maximum speed up we can get of a system. Similarly, if the number of stages is very high, the next one, what will be the average instruction executed per instruction cycle, or what will be the speed up of the system, or what is the performance of the system? That means if I increase the number of the stages to a very high, that means we will get the infinite number of speed up. No. See here, what is the maximum speed up we can get? So s tends to infinity. Same thing, we divide numerator and denominator by s. So the thing is 1 plus n by s plus nc minus nc by s. So this term and this term will be 0 because s is equal to infinity. So this is the maximum speed up we can gain if number of the stages is very high, that means infinity. In a question, if it is asked the number of the instruction is very high, then what will be the performance? Then you have to give this formula. And if it is asked if the number of the stages in an instruction is very high, what would be the performance of the system? Then your answer will be n by 1 by n plus c. Clear? So this is for today, and